Hello, welcome to SkyMap, where we explore the wonders of the universe. Today, we will be diving into the mysteries of our solar system and talk about one of the most mysterious planet, Mercury. But before we start, don't forget to subscribe and hit the notification bell so you never miss out our exciting space content. Mercury, the closest planet to the Sun, is a fascinating world on its own, right? Let's take a closer look at its size and what makes it unique. Mercury is the smallest planet in our solar system. In fact, it's even smaller than some of the largest moons in our solar system, like Jupiter's Ganymede and Saturn's Titan. To put into perspective, let's compare Mercury with our Earth. Mercury has a diameter of about 4,880 kilometers, which is roughly 38% the size of Earth. That's even smaller than some countries in our planet. If you could place Mercury on the Earth, it would fit nearly within the borders of the United States, with even a little room to spare. When we talk about mass, think of it. How much stuff an object has. Mercury is about 18 times lighter than Earth. Imagine 18 Mercuries stacked together. That's how massive our planet is. Mercury's mass is 3.3011 into 10 to the power 23 kg. But it is made up of more denser and heavier elements. Just for example, the percentage of heavier elements like metal present in these two planets are 70% in Mercury and 30% in Earth. According to that, Mercury should be more densely packed. Let's see the density of two planets. Mercury 5.427 gram per cc and Earth 5.519 gram per cc, making Earth the densest planet and Mercury the second densest planet in our solar system. But why? Mercury has low mass, so its gravitational pull is also weaker than Earth. For perspective, Mercury's lower mass makes its gravitational pull 2.7 times weaker than Earth. So, Mercury's weak gravitational force is unable to keep the objects as densely packed as Earth, despite having a more metal-heavy core. In spite of being relatively small, Mercury has a surprising G value. It's about 3.7 meter per second squared. Let's shift to our home planet, Earth, where the G value is approximately 9.81 meter per second squared. That means you will be 2.7 times lighter in Mercury. Look at the simple video for better understanding. First, let's talk about Earth. Our planet orbits the Sun at an average distance of 150 million kilometers or 1 astronomical unit. Light, which is the fastest thing in the universe, takes just 8 minutes and 20 seconds to reach us from the Sun. Now, Mercury orbits the Sun at an average distance of about 58 million kilometers. For light, it only takes about 4 minutes and 20 seconds to reach Mercury. For this proximity, the Sun appears 3 times bigger on Mercury. Mercury's atmosphere is incredibly thin compared to what we used to on Earth. For example, the most powerful vacuum creating machine on Earth cannot create as much vacuum as the Mercury already has. Scientists believe once Mercury had a good amount of atmosphere, but the extreme heat of Mercury made the atmosphere even thinner. Moreover that, the smallest planet's weak gravitational force cannot keep the air gravitationally bound. So the strong solar wind wiped it off. What Mercury currently has is called surface-bounded exosphere, mostly captured from the solar wind. Now it's primarily composed of tiny bit of oxygen, sodium, hydrogen and helium. Mercury is the closest planet to the Sun, which means it experiences extreme daylight temperature that can reach over 400 degrees Celsius. But when Sun sets, due to the lack of atmosphere, the temperature drops drastically, reaching around minus 170 degrees Celsius. Mercury's axial tilt is extremely low, about 0.01 degree. So both poles of Mercury always experiences about minus 90 degrees Celsius. Surprisingly, scientists have found water ice in the craters of Mercury's poles, where sunlight haven't reached for last billions of years. Finding water ice this near to a plasma ball is truly fascinating. Despite all, do you know the second closest planet to the Sun, Venus, is the hottest planet in our solar system, reaching almost 482 degrees Celsius, which is the highest recorded temperature till date. We will talk about it in a different video. Before understanding the magnetic field of Mercury, we need to know the reason behind the magnetic field formation. If any planet has a molten core and a high rotational speed, it creates a spinning motion throughout the molten core. This is called the dynamo effect. Due to this dynamo effect, the planet gets its own magnetic field. If you want to know more about the dynamo effect, please write down in the comment section. I will make a separate video on this topic. In the case of Mercury, it has an iron-rich core, almost 70% iron and 30% silicon. But it takes 59 days to rotate once on its axis. According to many scientists, this slow rotational speed is the direct cause of Mercury's weak magnetic field. And indirectly, it's the cause of cooling and shrinking of the iron-rich core, which also forces the planet itself to shrink. To give a perspective, Mercury's magnetic field is approximately 85 times weaker than Earth and losing its strength every day. However, when Mercury's highly elliptical orbit combines with the Sun's strong gravitational force, it creates a squeezing and expanding effect on the planet. To some extent, it helps the magnetic field to stay in place, just like the Jupiter's most geologically active moon, Io. When something like an asteroid or a comet crashes into a planet or moon, it creates a dent or hole on the surface. It's called crater. Despite being relatively small, Mercury has a lot of craters, like our own moon. Mercury's surface is built like a cosmic punching bag. It doesn't have a protective atmosphere like our home planet. So when space rock comes, it doesn't burn up or break apart. It smashes right into the surface, creating craters of all size. On the other hand, the Earth has geological activities like tectonic plate movement, which hides the craters over time. Due to the absence of geological activity, Mercury still has the proof of early and late heavy bombardment, which happened 4.1 to 3.5 billions of years ago in our solar system. The biggest crater of Mercury is called Caloris Basin. Its diameter is of around 1550 kilometers. The impact was so strong that it created a ring of over 2 km tall surrounding the whole crater. One of the most distinctive features of Mercury is the presence of narrow ridges, extending over several hundred kilometers in length. This is the proof of Mercury's gradual cooling and contracting. It's another proof of shrinking core, as we discussed earlier. Visiting Mercury is one of the toughest missions for each and every space organization. If we send a spacecraft, it will need a perfect amount of braking to stop at Mercury. Otherwise, the Sun will swallow it like a grain of sand. Sun's gravity is enormous in front of Mercury. In this situation, scientists discovered a unique route to slow down the probe. In this route, the orbiter needs to go a longer way. It has to orbit the Sun 15 times, with the gravity assist of Earth once, Venus twice, and Mercury thrice. On the fourth attempt of Mercury flyby, it will be slow enough to enter the Mercury's orbit. It will take around 6.5 years to reach Mercury. Back in 1970s, NASA's Mariner 10 became the first spacecraft to visit Mercury. It made 3 flybys of the planet between 1974 and 1975, capturing the first close-up image of its surface. Fast forward to 21st century, we have NASA's Messenger spacecraft, the first orbiter mission to Mercury. Messenger spent 4 years in Mercury's orbit, when NASA's expectation was only 1 year. The mission was a huge success. Today, whatever we know about Mercury, 90% of that comes from this mission. The next mission for Mercury, named Bepi Colombo from European Space Agency ESA, has already completed its first flyby on 1st of October 2021 and planned to enter the planet in late 2025. We haven't talked about the revolution, rotation, and orbit of the Mercury. In these 3 topics, Mercury is very different from Earth. If you want to know more about the same, please let us know. It deserves its own video. If you found this cosmic journey as fascinating as I did, please give this video a thumbs up and share it with your friends and family members. And remember, keep looking up, stay curious, and explore the mysteries of the night sky.